start the engine. Energy, so what I would like to start today is to kind of give you a kind of an intuitive picture of these three fundamental quantities, which are the curl, gradient, and divergence actually. They are very easily calculated. We know how to calculate them, but quite often people are not comfortable with them actually. What do they mean? Okay. So what we are seeing at the moment is what? So what is your guess what we are seeing at the moment actually? Okay, so there one of the obvious things that you can see is that I can treat this as that this is a part of a space on which these small balls are kind of moving around actually. That's the first picture. You can see. But mathematically, you can also think over it that okay, this kind of also represents the flow of something over it. Balls are kind of flowing over for some reason. What would be a mathematical meaning of it actually?
So a vector field is moving
That's
on
a
the
vector field
surface.
actually. Yeah. You can say that what we are looking at the moment is a vector field. Okay. So in other words, so that's a part of a space. To each point of this path, I can increase, for example, these number of particles, and I can go more crazy. Okay, so now I can say that to almost each point I have a particle sitting actually, and then replaced by a new particle. Okay, so which is like a, so I mean, if I take a particular point, on that point, no matter what particle is entering and leaving, it's just moving in that direction actually. Say, for example, you can pick a point actually and see what is, the direction of the particle on that particular point. You can see they always have a fixed direction. Okay? So in this manner, you can say that you have a part of a space on which something is flowing. In other words, you have a vector field defined over it. And now I would like to talk about, for example, what is the meaning of, say, divergence of the vector field? Okay. So by divergence you mean this. All these are curl, gradient, divergence. They all are the local quantities. Okay. So they are point dependent. They depend on P of t. Okay. So they are point dependent. Okay. So what essentially it says that imagine you pick a point. Let's fix a point actually. So let's just fix a point. Just think about the point. And just look at it, that what is happening around this point. So what is happening around this point? Or in that, So you see particles are entering into the region and then they are leaving. Entering and then leaving. Are you getting the point? So, how about if I, for example, I can pick a particular point and think, about it that the particles are entering and leaving. But how this point is different from, for example, this point?
The rate of entrance and leaving is comparatively high.
Comparatively high. Okay, so the more particles are entering and more particles are leaving. How about those who are at the corner?
Very slow.
Okay. So divergence measure this. So whenever you are talking about, for example, divergence of a vector field, you are actually saying that okay, if I have a vector field and a point, okay, and I look at the region around that point, okay, how much of his stuff is leaving and how much of his stuff is staying actually. Okay. So what should be the divergence here, for example, at this point? they are entering and leaving. So I'm going to say the divergence is 0 here. Okay, they are not staying. Are you getting the point? They are not staying inside actually. Okay, so the divergence is 0. But the rate is different. Okay. So think about it. If there is a region, so what would be the divergence at this point, for example?
Constant numbers.
So you're going to say, somehow things are being collected at that point. So things are entering. Imagine that's a kind of a point actually, that where things are, the balls are being collected at one point, but they are not, for example, leaving, unless we see the other side, that what is happening on the other side. Maybe they are not stationary, but if I assume at that point that, okay, they are being all collected in a region, okay, so I have a point, okay, this region, and, things are kind of being collected. So what are you going to call such kind of a points actually, and they are not leaving on this. You're going to see it's the opposite of the divergence. Okay, so it's like the negative divergence. Huh? They are being converging at a point actually. Okay. How about positive divergence, for example? So by positive divergence means that, okay, if you have a bunch of things, they are kind of leaving the region, okay, in all directions.
So in the first one, they are entering but not leaving.
Yes, they are entering but not leaving. If we assume it that they are entering but not leaving, then it has a negative divergence, while this guy has a positive divergence. What would be the meaning of zero divergence?
The number of leaving elements is 0.
Things are basically just going one way actually.
Yes.
So can you look at the different parts of this picture and spot some parts where you have a positive divergence and negative divergence and zero divergence actually?
Yes, sir. जहाँ से इधर हो रहा है वो हो जाएगा convergent.
So if I say what would be the divergence here?
0.
So 0. Why? Because
Things are
they
moving
are
in one
entering and
direction.
leaving actually. So divergence. Okay.
Which is divergence
And
negative or positive.
rate could be different. For example, here you also have a zero divergence, but it's going at a faster rate actually. Okay. The way they are leaving the place and entering the place is different actually. Okay.
On the top, divergence will be positive.
On the top, the divergence is positive. Okay. If I take, for example, this point, one of the points, what do you say about the divergence here?
Zero.
Negative.
Zero.
It should be still zero. Should be still zero. Why? Because they are entering and leaving. So where is going to be the positive divergence?
So from a starting point.
So really the beginning is the kind of a thing that they are, I can't see at least in this picture that they are, entering and leaving actually. Are you getting the point? Okay. You can also see the picture, another way to look at this is basically say, see the field vectors actually. Okay. Field vectors. So now, so that's a field vector, the same picture actually, but written in the terms of the vector. So every point has been decided. So it's like so you have it, but you are kind of seeing a vectorial representation of it. Okay. So if I, for example, take any point here, what is happening with the vector? Okay. So entering and leaving, actually. Okay, so it has a zero divergence actually, zero divergence. Okay, you can think of it that this is a kind of, it's a kind of a thing that is rotating actually. It's kind of a representing kind of a rotation actually. If you see, you can almost feel like there is kind of a rotation is going on. Wherever the things are rotating, you will not see spread. Can you think over it? You can have a, what do you call it? Cumulatively. Cumulatively. So it's like, I say that, okay, you can find a rotation here, and what is the divergence of the rotation? It's 0. You can even mathematically prove it, that if you take, for example, curl of a vector field, okay, and you compute its divergence, 0. Should be 0. Okay, should be 0. Can you see, what do I mean, where I am heading actually? So you have to think really, from different perspective. How about this one? What is happening?
Every vector is moving in.
So it's kind of a vector field. Cumulatively, if you see, it's a vector field with what? With a negative divergence. Actually.
Yes.
With a negative divergence. Okay. So can you see when? So if I turn it into the, kind of a picture with the balls, what will be happening with the balls actually? What do you think? They are not converging, but they are kind of sucked into this.
Yes.
This little part, and we can really see it.
सर यहाँ पे जो ये सर्कल्स हैं तो ये भी कोई चीज को शो कर रहा है
नहीं. These are just for your reference. So see the part, like a black hole.
Yes.
Things are being sucked in. So you're going to say, okay, it has, divergence. So the divergence is negative. Actually. They are being collected. Actually. Positive, negative. It's happening the opposite of it.
किस point पे negative?
ये भी अच्छा point है. I mean, if you're gonna see at, for example, boundary, so you see divergence here. The divergence is still 0. Okay, things are going and leaving and so on and so forth. But as you get close, to the middle, you're gonna see that the points are getting more and more kind of converging, and they're negative. ठीक है, is it making sense? What about? Divergence is representing that. So you can model everything for which you have such kind of a situation. When you're going to have positive divergence, think about it. In this picture, so imagine this is representing, space-time. Okay? Einstein, space-time is like a black hole. So what is going to be, so can you visualize the picture where the particles are going away from each other?
Expanding.
It
will be expanding something like
So suppose
the universe is
कर
expanding.
लेते हैं ये किस्म की कौन बन रही है ना, इसी के उल्टी कोई कौन हो, इधर तो जा रही है किसी पॉइंट पे, उससे जो है ना वो फिर आगे जो है स्प्रेड हो रही है एक पॉइंट तक, वो कन्वर्ज करी उससे आगे फिर ये स्प्रेड हो रही है.
That could be one of the other way could be that imagine you have this fabric, and pushing it from the down actually, and things are spread up. Okay. Now, this is one of the very interesting things people found about our universe actually. That okay, you have was kind of post Big Bang happened. Yeah, how we came to know that Big Bang हुआ है. So what are the fundamental that? So people did what? They observed that the galaxies are going away from each other. और वो जो दूर जा रही है एक दूसरे से, the galaxies are going away from each other, but the different galaxies have different rate at which they are going away. Okay, the galaxies that are far away from us are going more faster away from us. than the galaxies that are near to us actually. So the nearer galaxies are also going away from us, but at a lower rate. Okay. So, and the galaxies that are away from us, they are going more and more rapidly and faster from us actually. Question. Your F equal to ma doesn't explain it. Even Einstein equations doesn't explain it actually that. Why the heck this is happening? Okay. So whenever we think of, so you can have it, okay. So the galaxies are going away from each other. So imagine someone is making a movie and you rewind that movie, that means that they must have started over from one point somewhere. Okay? And singularity, some point with the infinite density where all of the entire mass of the universe is really concentrated in a single point. Okay? With the infinite density and then explosion. But the next interesting thing that they found is that the farther galaxies are going faster away from us, while the nearer galaxies are going at a lower rate. Actually, why they all have the same different what we call rates actually? And the answer comes that okay, we don't have that can explain it, so you assume it's like the dark matter actually. We have the dark matter which is responsible for it, and we can't see it. Okay? So that dark matter is doing what with this space-time fabric? Is doing the opposite of the black hole.
Dark energy is dark matter.
Energy is responsible for expansion. Actually, but
can we say that different velocities is because of their different masses? अगर कोई धमाका होता है तो मतलब जो हैवी चीज होती है
हम ऑब्जर्व ये करते हैं कि things slow down. But the trouble is that things are not slowing down. They are getting even more faster. The more far you look, they are getting more. Now that's weird actually. What explains it? So therefore people hypothesize is dark notion actually.
So if we get the place of explosion where Big Bang really occurs, so it will be easy. If we locate the place where the element with
you can't actually.
If you can.
We can't actually that where precisely in what space, because space itself came under the existence at that time actually. So there was nothing at all at that point. Anyway, so my point is this. So if you're going to have an opposite of space-time fabric, but you're going to have an opposite of it actually, then particles are drifting away from each other. Okay, and you will say that you have a positive divergence actually. So you have this J.
So can we say this is the complete example for expanding the black hole?
You can say it in many senses. Yes, you can say it. So in other words, you can assume that this is like the event horizon. Okay, of it. So if someone enters into the event horizon, you can't escape actually.
So
You are moving on the geodesics. In those who are doing differential geometry, you are moving on the shortest paths actually. Okay.
from this we can conclude that every star, they are in the same dimensions in 2D, they are at same level. As we can say, जैसे टेबल पे दो स्टार्स पड़े हुए हैं ना, तो मतलब वो एक दूसरे से 2D में ही है, तो सर हमें स्टार्स जो है ऊपर नीचे क्यों दिखाई देते हैं? सामने दिखाई देना या पीछे दिखाई देना?
This is just for example, if you go on moon, you want to see Earth, so it doesn't mean that you have to look down. Earth is there. It's going to be down. It's just a way of looking at it. Anyway, so I hope you got some idea of divergence actually. What we mean by divergence, and then I'll share you. You can think of different vector fields and you can talk about it. Okay, what is happening? For example, can you spot some points where you have positive divergence and negative divergence? For example, this field में something like that. What is happening with it? Okay, I mean, you can see it more precisely. Okay, but the good thing is try to predict it from this way. But the other way could be that, okay, you see the field vectors. Okay, you see the field vectors. Okay. And then you can have that. What is that?
So positive डायरेक्शन जो इन दो पॉइंट्स डाइवर्जेंस इन दो पॉइंट्स के दरमियान से निकल रहे हैं ना, क्योंकि इन जो वेक्टर्स हैं वो इन पॉइंट्स में से निकल रहे हैं.
So it's kind of a rotationary again kind of a system actually. Okay. So you see that all of these curves, but they are rotating. It's not like that. If they skip actually, if they leave rotating, then you can maybe talk about the divergence of it. But
So we can say, with an isolated system, we can say divergence is here.
जरूरी नहीं. For example, आप एक पंप लगा दें मिड जमीन में, ठीक है, and you look globally on it actually. It's not a local picture, it's globally. So what is happening?
Isolated is nothing can enter and nothing can be
Yeah,
done.
मैं कहता हूँ imagine, so you have this, so you have, for example, in a lawn you put some water source actually. So what will happen? You see that it's spreading out actually. Okay? Spreading out. You're going to say, right in the middle where you have source, you have positive divergence actually. These things are okay, diverging out from that point, okay, being originated. Okay, so the source point really. And if you see all other points, you can have divergence 0 because water is entering and leaving. Yeah, the entering and leaving actually. Anyway, so you can see the vector fields and have a judgment that what kind of things you can have. So I hope we got some sense of divergence. Okay. So and we got some sense of vector field. So vector field, this is vector field. But this vector field is a consequence of this, not this, but okay, whatever. So that's a vector field, but this vector field is a consequence of, it's basically representing something. So whenever you think of a vector field, you must keep in your head that, okay, maybe the balls are going in some way actually, these tiny white balls, or maybe something is flowing in a particular way. Okay? And the vector field is just an indicator actually. It just tells you that how particles are leaving from one position and moving to the other position. J. Now I would like to talk, what do you mean by curl actually? Curl. Now curl is something very interesting. You have to be very careful when you are, for example, dealing with a curl. So curl is something. So you have a vector field, okay, you want to know, so you pick a point and you want to know how much of rotation is going on at that point actually. Okay, rotation is going on at that point. Okay. So can you see a kind of a rotation? So when you're going to have a rotation actually, when you're going to say that they are producing kind of, the particles are curling. Okay. What do you mean by it? So does for the curl, the thing has to go always and round and round and round. It may have curl, obviously. But as last time we discussed that even things which when they are going flow, going for example in in straight direction like the water in the say river, okay, you don't see maybe the things are not rotating, but still there is curl. So you want to know what is the curl at this point? So try to put a toric here actually. So just take a piece of a stick and put it, and see that whether that stick will have some rotation or not. Some rotation or not. That rotation will be produced if some particles are going faster and others are going slower actually. So if they are everything is going with the exact precise same pace, obviously there isn't curl. Okay. But if you think that some particles are going faster and some are not, then you're going to detect curl actually. So for example, in this picture, so these are like the curl detectors actually. Now think about it. What is happening with this? So in other words, so this is like a twerk. This is like a twerk. This is like a piece of a stick. The question is, are these twerks are changing their directions?
Yes, sir.
So in other words, if you track this yellow one, so is this yellow is kind of a rotating a bit or not? Okay, so you have to think carefully about it. If it is rotating, so it's changing its orientation a bit actually. You're going to say that, think about it, so track this white one.
Also, they are not rotating.
Not rotating. Rotating.
No,
Not
sir.
rotating.
Not rotating.
Huh? So think about it. Take the green one.
तो कोई भी नहीं कर रहा है
None of them. Okay, so it appears